Hello and welcome back viewers to the lecture series on linear algebra. This is the first lecture on linear algebra where one of the important topics of linear algebra, which is vector space, will be covered. First we will understand what is a vector, followed by the idea of vector addition and scalar multiplication. This is one of the critical or important idea which will be used multiple times in the lecture on linear algebra. Then this will lead to us to the idea of vector space followed by its property, and also we will also show how vector will be represented in Cartesian coordinate. What is vector? Vector is a mathematical object that has both magnitude. Here magnitude can represent the size of the mathematical object or the length of the mathematical object, and the direction of that mathematical object. So vector is represented using the following notation. So let's say we have to represent vector u, which is given the name AB, where A is the initial point or the tail and B is the terminating point. So this can be represented with an arrow, upward arrow, or the bold character. So in short, to represent vector u, because here A and B are assumed to be given, so we don't generally take the initial and the terminating point. We assume that is considered by the viewers. So u can be represented with an upward arrow or bold character. Here magnitude actually represents scalar quantity or the numerical value. Coming to the idea of how these vectors is used for calculating vector addition and how scaling is possible through vectors. So let us consider two vectors u and v, where u is represented with the blue line and v is represented with the red line. So to follow vector addition, the tail or the initial point should match, and then by the parallelogram law, where we assume that there is a parallelly another set of vector which is represented by dash red color and parallel to v another set, so the diagonal will give the resultant addition of those vector. Now how scaling of that vector takes place? So for that we assume that for a vector some scalar is multiplied, which is generally represented by lambda. Lambda can take any real number. It can be -1, -0.5, 3/4, 6, 7. So that is the scaling of vector. So for the illustration purpose, I have considered lambda as 2. Vector space is the collection of vectors. Space generally in mathematics is representing set. So that means the ordered collection of vectors. Here ordered collection is important because if suppose you write u plus v, that becomes meaningless without writing u and v. And if you write u and v in any order, it will make sense, then followed by u plus v. 10 properties of vector space that needs to be followed for two vectors to be part of vector space. So property number 1 and 7, which is the closure of vector, so that means that it should be a part of that set of vectors. So property 1 is about vector addition and property 7 is about scaling of vectors. So this should be a part of that set of vectors. If it is not included in the set of vectors, then it is not in vector space. Then the commutative property, which is followed for addition as well as for multiplication. Then associative property, where you take the three vectors and assuming that these three vectors are included in vector space, then order of that addition will be equal. And property number 4 and 5 are basically distributive properties. So either you take a constant and add to the vector, or multiply those vector with a constant. Then this is property number 8 is very important, which is a zero vector. So this will give us the same vector, and property number 9 is that we need to find the additive inverse of this same vector, and property number 10 is dealing with the multiplicative inverse. So 1 times u will result in the same vector. So if we take the inverse also, it should be same vector. Now we have addressed the properties of vectors. Now, how to represent vector using Cartesian coordinate? So let us consider that we want to represent vector v, which is 3i plus 4j. I here basically is the x coordinate, and y generally, j is the y coordinate. So 3 from the 3 at x and 4 at the y, 4 distance away from the origin. So this will give us the point 3i plus 4j, where the origin is actually the zero vector, where the magnitude of that vector is zero, but it has some direction. So this is the representation of vector. So that 3i plus 4j is actually a point in that space. Thank you everyone for joining us today. Don't forget to like, subscribe, and hit the notification bell to stay tuned for more exciting lecture on linear algebra. Until next time, keep exploring. Thanks once again.